Hello and welcome to this session. Hope you're having a great day. In this session, we're going to cover service management and service delivery. And we've actually got quite a bit to go through, so I might as well just get right in. This is actually the first module of series number 3. The third series is on enterprise service management. As you can see from the modules we've already gone through, this is all about bringing an enterprise context to cloud computing. And in a lot of instances, we go beyond cloud and we talk about some of the underlying capabilities, which we may not get to see, but that enables us to create a complete picture and hopefully allow those who are coming from an on-premises environment to more easily transition into some of the key terminologies that they are most likely going to encounter when working on the cloud. So this is the agenda for this session. In most of these sessions, we always start with key concepts and definitions, and then we get into the detail, right? So in terms of the detail here, we're going to talk about provider viability, how to essentially select the right provider. We're going to talk about service contracts, pricing, costing, and billing in the cloud. And then we're going to end with a discussion on the all-important topic of monitoring, service level agreements, and quality of service. So let's start off with some key concepts and definitions. Now, one of the concepts you definitely will come across, especially when you're using services such as application platform services, is this notion of a limit. So what is a limit? A limit is a floor. It could also be a ceiling that is imposed on the amount of resources that can be utilized by a given entity. So it's all about creating some sort of quota, right? Some sort of allocation. So in order to limit spend. Then the second concept is reservation, and reservation is a mechanism that ensures that a lower limit is enforced, right, for the amount of resources guaranteed to an entity. So reservation more or less makes sure you have a minimum allocation. Yeah, so two important concepts because in the cloud we're constantly allocating and deallocating resources, right? So these two terms help us to have a level of certainty, right, in terms, or at least the boundary limits, kind of deduplication or duplication there, but you get the point, right? So it's important to have an understanding of the extent of the limitations or the boundaries within which we're working. The next concept is IOPS. Now, if you see the word or the abbreviation IOPS, that refers to input output operations per second. You typically see this when talking about disk performance, right? That's where you're most likely going to come across this. So IOPS refer to metadata. Let me rephrase. Metadata performance is a measure of how quickly files and directories can be created, removed, checked, or checked on a disk resource, right? And we typically talk about that by using the term IOPS or input output operations, right? So like I said, IOPS is usually linked to performance of disks. Caching, we actually discussed caching in an earlier module, right? So again, very important concept, right? Caching is very important because it helps us improve performance, right? So caching is the mechanism for improving the time it takes to read from or write to a disk resource. And it's not just disks, right? So you can also cache in order to optimize or reduce the time it takes for a compute engine resource to process a transaction, right? If a compute engine resource is serving static content like images or videos, you may want to cache that at a location closer to the end user, and that way it doesn't have to be served by the back end. So caching is a very important concept, and this applies as well to disk resources and others. Bandwidth is a measure of available or consumed data communication. So the amount of bandwidth that we've got available has an impact on performance. So at home, for example, I can't remember now if it's 500 megabits per second or a gig, right? But I have a service from Virgin, which is fiber based and quite fast. And the reason why is because when I teach, when I deliver Google Cloud training, I'm uploading a lot of information, right, to the participants using streaming technology. And so I do require the bandwidth, right? My backup also has, sufficient bandwidth, and it's over a 5G network. I have two 5G networks, or two providers, a service from two providers, for redundancy purposes, in case, so I have a total of three options, right, in case any of those should disappoint, right? But they all need to have sufficient bandwidth, right, for those options to be viable. What about throughput? So throughput is the amount of data that can be realized between two network resources, right? So the amount of data that can be essentially made accessible across two resources. Now, one of the interesting things when talking about throughput is what we refer to as a saturation point. So as transactions increase, right, based on throughput, there comes a point where there becomes diminishing returns, right, where basically degradation in performance sets in, and that's what we refer to as the saturation point, right? The ideal In an ideal design, you don't want to get to the saturation point, right? You want to scale up just before you hit the saturation point. Jumbo frames. I haven't actually come across this explicitly on the cloud, but again, important concept to be aware of. Jumbo frames are large frames that are used when large data transfers to let me rephrase. Jumbo frames are large data frames that are used with large data transfers. The reason these are important is because it helps us lessen the burden on processors. Right, so that's jumbo frames. Okay, and network latency. I think we've probably come across latency before, right? Network latency refers to the delay typically incurred during the processing of any network data. So we typically talk about latency from the point of view of a web experience. So you go to a website, you type a URL, and it takes time for you to get a response back, right? So that service has a much greater latency. Now, it's important, especially within the cloud, where you've got services interacting with each other, because some of those services have a timeout configured. So they wait for a certain amount of time, and if they don't get a response back, they assume that the service at the other end is not working. So if you have latency, the latency can increase the amount of time it takes for the service to return, not because the service isn't working, but because of the network, maybe network congestion, right? So latency is something to definitely consider. Quality of service. So quality of service refers to a set of technologies that provides the ability to manage network traffic and prioritize workloads in order to accommodate a defined service level, right, or of a cost-effective solution. So generally speaking, all cloud services provider will have some sort of indication of the quality of service you can expect. The quality of service statement, the promise that they make, is typically backed up by a service level agreement. And the service level of agreement usually has, depending on, whether or not they're able to deliver to those promises, they may actually offer some sort of compensation, right, of some sort. Multipathing, right? So one of the key reasons why the cloud works so well is because of the level of redundancy that's built into the cloud. So multipathing is just one of those. So multipathing is the practice of defining and controlling redundant physical paths to input-output devices. Right, so the reason being that if one of those paths should fail or should not be functioning as expected, there is a redundant path that can be used, right? That's the whole idea behind multipathing. Load balancing, we're going to see a lot of different types of load balancers when we get to the cloud. Load balancing is a networking solution that distributes incoming traffic among multiple resources. Right, so this is a key mechanism or a key system on the cloud. And then scalability, that's another very important capability on the cloud. So scalability is the ability of a system or network to be expanded to accommodate workload growth, right? Scalability is very, very important. And you can see here that there are two ways in which you can scale. You can scale horizontally. Horizontal scaling means having more instances. So you can see in the example here, you start with one server. When you scale horizontally, you add three more, you end with 4 servers. Scaling vertically, you start with a machine with a certain amount of memory and CPU. When you need more capacity, you replace that small machine with a bigger machine, right? So you're basically, you end up, you always have just one machine, but the machine is bigger than the previous machine, right? If you need more capacity. Virtual machine templates. So virtual machine templates are standardized groups of virtual machine hardware and software settings. That's a key word. A template captures configuration, it captures settings, and a template is used to create the actual virtual machine instances. Right. That again is something we're going to see when we get onto the cloud. It's used quite extensively across cloud platforms. Elastic resource provisioning. Elastic resource provisioning establishes a dynamic resource provisioning system that ensures the customer is granularly billed for exactly the amount of resources that they use. Now, this is a key promise, a key tenet of cloud computing. Cloud computing, we talk about this notion of utility pricing, the fact that you pay for just what you use. And this is a key mechanism that enables us to be, or providers to be able to deliver to that. Clearly, you can see the benefit here. Without elastic resource provisioning, if you have a service that requires variable resources, you have to optimize, or you have to provision for peak. And that results in a lot of wastage. You can see the wastage there, right? Unused resources. With elastic resource provisioning, capacity more closely matches the requirements. High availability, right? So what's high availability? High availability ensures that a system or a component is continuously available for a predefined period of time. Right, so very, very important concept again in the cloud. Generally speaking, there are many mechanisms you can use to enable high availability, and these mechanisms have different implications from a cost perspective. For example, you can achieve high availability within a single region, because when cloud providers deploy services or create infrastructure within a single region, there are usually multiple fault domains. In other words, multiple independent locations where you can host your resources. And if you place them across those independent regions, then you've got a level of high availability. However, what happens if there is a natural disaster in that region? Now, if you're concerned about regional availability, you can also spread your workload across multiple regions. Now, in that case, you have data kind of flowing across the network between these regions. That usually results in additional costs. So again, there are implications, there are cost implications, but you do have the ability to significantly enhance, right, the level of high availability that is, and again, you would select the right option depending on the type of service. Downtime. Downtime is something that, again, you're going to come across in the cloud, right? Nothing runs forever. Systems need to be maintained, right? So downtime is used to describe a situation where an end user cannot access a service or application because it's been taken offline for maintenance or for any other reason. Sometimes you have downtime because of a defect, because of a bug, or because of a problem. But there are other occasions where you've got downtime which is scheduled, right? Because of a scheduled maintenance event. What is the recovery time objective? The recovery time objective, that's a very important term, right? So it's typically used for backups, right? So recovery time objective is the time it takes to be able to recover, right, in case of a failure. Now, there are different types of ways in which you can configure your system for disaster recovery. One of the options is where you have like a hot site. So you've got basically maybe two environments. You've got your primary environment where, which is serving a majority of your users, but you also have another environment which is smaller, but it's also active. It may even be serving some traffic, but not as much as the primary environment, or it may not be serving any traffic whatsoever. So, but in that case, because it's the other environment is alive, you've got data being replicated across the two environments, and the application is fully deployed across both. So clearly, if there's a disaster, The data and the systems are already there. You may have to scale it, you may have to increase the number of instances, but the recovery time objective will be much smaller, minutes or even or hours at the most. In the case of a warm site, right, you've basically got some infrastructure available, on the warm site, but it's not running, right? Or maybe it's running, but you don't have the data. Maybe you have a backup, right? But you don't actually have, the data. It's not available, right? So we hot is accessible, it's running, it's ready. Warm, you've got the data, the application, the systems are currently set up, but they are not being used. They are not accessible. So you need a little bit more time in order to activate, right, the warm site. And then with the cold site, that's basically a site where you basically need to, get the data, set up the system, right, and then, get the backup or at least get the data from a backup that was taken previously. So cold sites can take days and weeks, right, to set up. Yeah, so the bottom line is there are options, and depending on your risk tolerance, you may choose one or the other. Okay, so that those were some concepts and definitions. Let's take a look at a discussion, or let's discuss ways in which you can, select the right provider. And also, we're going to take a look at service contracts as well in the cloud. So in terms of selecting a provider, these are some, considerations that could be relevant. When selecting a provider, it may be useful to think of just how much you can trust them to be around, right? How long have they been in business? How financially stable they are, right? So, that's definitely worth considering. Also important to think about not just, what they have today in terms of the services that they offer, but also the history. How innovative are they, right? And can you rely on them to be at the leading edge, right? To provide you with what you need, right? What about their backup and recovery strategy? How many regions around the world do they have facilities in, right? Within each of those regions, how many fault domains or failure domains do they have? And also, how transparent are they in terms of their strategy, in terms of their financial status, in terms of maybe key clients that they've worked with before, right? Are they too small? Is there a risk that they could be taken over? Because sometimes when organizations are taken over, the terms of business changes, the priorities change, and you may end up being forced to migrate because the new owner doesn't share the same vision as the previous company. What are their current practices, right? Which other third party vendors do they work with? Do you perceive a risk in that relationship, right? Do they rely on third parties for their infrastructure? Do they own their entire infrastructure? One of the things I like about Google is that Google owns its own fiber, the fiber that connects its data centers around the world. A lot of other cloud providers lease those facilities. Now, if that's of concern to you, you may lean towards a provider such as Google. Online reviews and past provisions, the ability to adapt to client requirements. That's where references come in. Customer references, do they have good ones, right? Can you actually validate what those references actually claim? Technical certifications, right? Now you have technical and you also have regulatory certifications as well, right? So ISO 2000, 27001, what about HIPAA and PCI compliance? There are many certifications and standards that could be of interest to you. How do they deal with security? How secure is their platform? What are their policies with regards to privacy? Is there a chance? I mean, when you raise a support ticket, do you have visibility of what what they're accessing on your platform, or are you completely blind to that, right? What about the level of maturity in terms of their operational processes? Do they have they embraced site reliability engineering practices, which are designed or which enables organizations to be a lot more proactive in terms of reactive to incidents? Right? What about their support for open standards, right? Are you going to be locked in, right? Are you going to be able to easily move your workload if you chose to, right, onto another provider, right? Do they have support? Do they have third-party audits being conducted, right? Do they comply with key certification, programs? So again, a lot of these are things that you should really reflect on before selecting a cloud provider, right? Terms of service. What are the terms of service? So, for example, a service usage policy. I mean, these are things that you're going to come across, right, as you're working on the cloud, especially if you're in management, if you're in management level, right, because they do help you make decisions or at least understand what you call understand roles and responsibilities. Because remember, when you're on the cloud, there is a shared responsibility model at play, right? You are responsible for certain things, and the cloud provider is responsible for certain things as well. So these terms of services documents help clarify exactly what those responsibility boundaries are. One of the documents that you'll probably review is a service usage policy document. So this defines the terms that govern usage of services, right? The methods, the conditions, right? And right, this also talks about actions, things that you can expect if there are violations, right, of these terms. Then you also have security privacy policy documents, very, very important because, as cloud services providers, sorry, when using a cloud service, you're deploying workloads, you're deploying applications that are processing or storing potentially sensitive, private information about your clients. So the security and privacy policies are very important, right? So it's useful to be aware of what those are. Warranties and liabilities. So these describe the warranties and liabilities, risk, provisions for compensation, right, for non-compliance with SLAs, because things do go wrong, right? Cloud providers sometimes find themselves in a little bit of a nick because someone made a mistake with the configuration, and there've been instances where an entire region has gone down because of a misconfiguration, right? What about your rights and responsibilities, right? So this again is important. The cloud is a shared responsibility model. So understanding very clearly what your responsibilities are and what the cloud provider's responsibilities are, extremely important. What about contract termination and renewal, right? What are the conditions that govern renewing contracts or terminating contracts, right? Again, those are important to be aware of. Some additional consideration with respect to public cloud terms of service, right? So generally speaking, public cloud services don't really have that much warranty. I mean, if you are an enterprise client and you sign up to an enterprise service, there are SLAs, and SLAs typically come with some sort of warranty or some sort of guarantee. I mean, it's never really sufficient, right? Because you're talking about business impact, and it's very difficult to quantify what that is. But again, very useful to be aware of what level of compensation is available. But like I said before, in most cases, it never is sufficient, right? So, but there are some levels of compensation that cloud providers may offer. Hardly ever more than what you've actually spent with them. Kind of makes sense, I guess. Liability limitations do not offer compensations for most kind of damages, right? Now, warranties are not provided for performance metrics or to guarantee service continuity. That's why you have options for resiliency or high availability, right? So if you want a level of availability, you need to configure your application in a specific way. Then the cloud provider will guarantee a certain level of availability. Right now, if they fail to guarantee that level, then in most cases you have some level of recourse, right, to compensation of some sort. But like I said before, never really sufficient, right, given the nature of most businesses. Now, cloud providers typically have minimal. That's what I said. There's usually some sort of minimal level of compensation or responsibility. So cloud providers have minimal to no responsibility for data security breaches and damages incurred from those types of events. Now, that may be true from the point of view of the contracts that you get into, but also remember that they do have an obligation. And if they fail to protect customer data based on expectations that have been set by government, they could be exposed to fines, right? And a lot of providers have actually had to pay a lot of money for security breaches, right? So there are ways in which they can be penalized. The cloud provider can unilaterally modify terms and conditions without prior notice. They usually give you notice. They usually tell you ahead of time, but they do have the freedom to change their terms and conditions as needed, right? To survive as a business, right? So yeah, so they can change, they can make changes to contract terms and conditions. And of course, when that happens, that's why portability is important, because if you find yourself in a situation like this and the terms are no longer acceptable, it's important to be able to migrate off the cloud platform to another platform. And if you've locked yourself in other words, if you've used services that are only available on this particular cloud, you may find yourself in trouble. Let's talk about cloud contract structure, right? So what is a cloud? What does the structure of a contract look like, right? So typically, these cloud contracts typically have a section that describes IT resources and quality of service guarantees. It also provides an indication into the monitoring and measuring service quality metrics with benchmarks and targets, because if you've got things like SLA, service level agreements, those agreements need to be measurable, right? There's no point making a promise if you can validate compliance against what was promised, right? So there are measurements, there are metrics, and those metrics are clarified in these documents. And the pricing structure, right, the model of pricing and the applicable fees, that's also usually quite clearly documented. And any legal and compliance sort of requirements, right, are usually stated, as well as audits that are regularly conducted, and accountability for that, and privacy, right, how they deal with how they ensure privacy of your data, right, and the warranties around that, right. And usually cloud providers, where they have a need to access your information in any way, right, or where they have a need to maybe share, information with security agencies or whatever, those, that has to be disclosed, right, in the contract structure. You need to be made aware of that as well, right? Any potential threats to data privacy needs to be disclosed. And typically, if these contract documents do not clearly outline this, they could find themselves having to pay a massive fine if found out to be in breach, right, of expectations. Information governance. So, what is information governance? Information governance is the classification of information, right? It's more or less a high level description of important information categories, right? So, it allows you to create different categories of information because information is not all the same, right? Information management policies define what activities are allowed for different information types. So once you've categorized your information into different types, you have policies that define the types of activities that are allowed for each of those, right? Because for very sensitive information, there will be a lot of restrictions in terms of how you can access and make use of it. Now, location and jurisdiction policies refer to where the data, the information may be geographically located, right? And there are legal and regulatory ramifications for that. So a lot of banks, for example, may be forced by local governments to store financial transactions locally within the country. As you can imagine, systems processing very sensitive information such as visa applications, birth certificates, those types of government-based systems. A lot of those systems run in data centers located within those countries. Right? A lot of the countries are very, very skeptical of hosting those types of services in the cloud. Authorizations define which type of employee or user are allowed to access which type of information. And on the cloud, you're going to notice that we have different types of mechanisms for authorization, for determining. Well, there are two things usually. What we need to do, first of all, is determine who it is, and that's usually referred to as authentication. So you need to provide something that is secret to you, that uniquely identifies you. And we can take it further by challenging you to also respond with something that you have in your possession. For example, we can send an SMS message to your mobile phone. So you need to have your mobile phone with you, and then you have to enter that code, a valid code, in order to be authenticated to prove your identity. Now, beyond that, authorization then defines what type of resources you're able to access. So that's the second level. Ownership refers to who is ultimately responsible for information, right? And custodian refers to who is responsible for managing the information at the bequest of the owner, right? So again, these are important topics or concepts that you're going to come across as you're working on the cloud, right? And dealing with with information. So next, let's talk about pricing, costing, right, and billing. So these are the different types of costs, right? There are different types of costs you can expect when working on cloud projects. The first one is what we refer to as sunk cost. So what is sunk cost? So sunk cost is investment that is made in existing IT environments, right? So, some cost is where maybe 3 years ago, 5 years ago, a big data center was built and it cost the company $10 million. That's sunk cost, right? The money has already been spent and somehow someone needs to be accountable to ensure that there's a return on investment. Upfront cost refers to the cost of purchasing or leasing new IT resources, right? So if you have just, you may have an existing data center, you may be, running all of your resources on premises, and the upfront cost would be the cost of buying additional servers for a new project. Ongoing cost refers to the cost for IT operations, essentially, for example, paying licensing fee, software licensing fee, electricity, insurance, labor, paying your staff, right? Those are ongoing costs. The cost of capital, a lot of the times organizations need to borrow money. So the cost of capital is a charge on capital, things like interest rates, right? Integration cost refers to the cost of integrating with a new environment, right? So you may integrate when when you need to do testing, right? Or when you've developed a component and that component needs to interoperate with other components, right? So you may need to, test the level of integration and the fact that just to validate that everything works as expected. Lock-in cost refers to the cost of moving away from your current provider. If you haven't been very careful about the types of services you're using, and you've used services that are only available with on a particular cloud, and those services are not based on open standards, the lock-in cost can be significant. You may have to rewrite your application in order to move right from that cloud provider to another environment. Okay, pricing models, right? So pricing model influences. So these are the things that influence the pricing model. So for example, one of the influences is competition, right? Clearly, if you've got a lot of competition, one of the things I always say, so in the cloud, a lot of the times you see a cloud provider being innovative and coming up with a new service, and the market or a lot of people complain about the pricing of that service. I have a view, maybe it's just because I've been around so long. I have a view that, well, market forces will actually regulate pricing, right? It's not down to the cloud provider, and that's due to competition. As other providers start catching up, they're going to come up with more competitive ways of pricing for that service, and the first mover will have to respond, right? That always happens, irrespective of how big they are, right? And also regulatory requirements may also have an influence because if you need, for example, to host your application in a jurisdiction which is more expensive, obviously you're going to pass those costs on. It's going to impact pricing, right? The overhead, right? The overhead incurred in designing, developing, and operating a cloud service also has an impact on price. Then there are other things, taxation. It's not on this slide, right? But taxation, the cost of labor, right? That I guess that translates into what we've just talked about there. But taxation is another one. Some regions, so for example, when you're on the Google Cloud, certain regions, for example, Brazil is quite expensive, and I've been told part of it has to do with taxation. In some cases, it also may have to do with the cost of energy, right? Because these cloud services require a lot of energy. Cloud data centers consume 2% of the world's energy, about 2%, right? That's a massive amount if you think about it. So there are opportunities to reduce expenses via sharing IT resources and data center optimization, right? So your ability to optimize, the way you use IT resources, that also could help you reduce your costs, right? So yeah, so I mean, and these are just what do you call a sample of influences. There are probably other influences. So let's talk about some of the ways in which you can manage costs, right? Cost management considerations. Service design and development, right, refers to pricing models and cost templates that are defined by the provider. So obviously, service design and development has an impact, right, on the cost. Okay, so and that's typically captured in some sort of pricing model and a template that's used for determining the cost, right? So it's, the design and development costs are usually factored in. Service deployment costs, right, take into account the architecture for usage measurements and billing related data collection. Service contracting refers to negotiations between the consumer and provider to reach an agreement on rates and usage cost metrics. So yeah, so if you're very big, so let's say you're the CIA, and remember there was a few, I think about a year ago, when the Trump government was still in power, there was a I guess there was an issue where a project was awarded to Microsoft. I think it was one of the government agency projects, and AWS obviously complained bitterly. I think Microsoft still got it, right? But generally speaking, when you have a large, project like that, especially a public sector cloud project, there is room for negotiation, right? And the rates, right, and usage cost metrics are usually agreed upon, right? They don't pay the same as what we pay on the public cloud because they obviously consume it a lot more. Service offerings are concrete offerings of a services pricing models through cost templates and customization option, right? So when we talk about a service offering, right, that's actually a concrete service that's available. And typically that service offering has a well-defined pricing model, right? And that pricing model was, kind of determined using some sort of cost template, right? With maybe some additional customization if required. Service provisioning refers to service usage and instance creation thresholds imposed by the provider or the consumer, right? So in a lot of clouds, you have this concept of a marketplace, and the marketplace usually has built-in automated provisioning of resources. So you have like a one-click install. Obviously, you typically have some level of customization that you can perform, but once you've provided the relevant input, you just hit a button and service provisioning just magically happens, right? So in this instance, right, the resources that are deployed, right, will be configured in order to be able to, in order to, I guess, in order to allow you to be able to have access to the service, right, that you're trying to access, right? So the relevant thresholds, etc., will be imposed automatically through that sort of automated provisioning process. Service operations refer to the active usage of services, which produces usage cost metrics data, right? So that's, as you're using a service, right, in a live environment, that's obviously, you're being usage of that service is being measured, right, and you're being billed accordingly, right, based on the metrics. Service decommissioning. So service decommissioning refers to when a service is temporarily or permanently deactivated, right? And in a lot of instances, when services are deactivated, they are most likely deleted or they could be archived, right? So yeah, so that's decommissioning, and typically you do that when you no longer require the service. Okay, so those are some cost metrics. Let's talk about pricing template formulation. We've made a lot of reference to pricing template, right? So cost metrics and associated prices are costs that are dependent on the type of IT resource that's allocated. And that's true, right? Because if you have, for example, a compute engine resource like a virtual machine, that virtual machine, the pricing can be based on an on-demand, right, cost sort of metrics, so pricing formulation, or it could be based on a reserve. If you reserve it for long-term purposes, you get it's more heavily discounted. Now it could also be on demand, but from a what do you call it, from a pool which is basically spare capacity. So that could also be cheaper. Fixed rates are based on resource allocation and define the usage quotas included in the fixed price. So a fixed rate, you can have fixed rate pricing where you basically make a long-term commitment, right? You make a long-term commitment to use a certain amount of resources. The cloud provider can then give you a discounted fixed rate, right, for that. Variable rates align with actual resource usage. Now, by the way, let me go back to fixed rate. There's a service on the cloud, or some service providers give you the ability to reserve an entire physical node or physical machine. And then within that physical machine, you can deploy virtual machines. That's useful for organizations that don't want to share the underlying physical resource. So in a case like that, right, because you're reserving the entire machine, you're having to pay for it. You're paying, whether you're using it or not fully, you're paying for the entire machine, right? And then depending on how long you reserve it for, you could actually, you may be able to get a discount, right? How long you're using it for. Volume discounts, right? So volume discounts typically refer to consumers that get a discount because they're actually consuming a lot, right? So, the more you consume, the more you can negotiate with the cloud services provider and get some additional discounts. Cost and price customization options are associated with payment options and schedules, right? So when we talk about pricing and customization, usually that relates to you being able to customize the pricing based on, let's say, monthly or annual installments, right? Again, also on long-term, commitments as well, right? Long-term reservations. So all of these types of issues are considered when formulating a pricing template. Pricing template alignment, right? So how does the template align to different types of services that are available on the cloud? Remember, we talked about in an earlier module, we talked about the different service delivery models, infrastructure as a service referred to as IaaS, platform as a service referred to as PaaS, and software as a service referred to as SaaS. You may even come up with obscure other options like data as a service as well as DaaS, right? But those are more, I mean, data as a service is usually put under one of these categories. So for an infrastructure as a service pricing template, right, the alignment is based on infrastructure resource allocation and usage. So we'll talk about things like virtual machines, network, storage capacity, etc. The PaaS platform as a service pricing template depends more on platform configuration, right? So things like the configuration of the software, the configuration of deployment tools and licensing. And SaaS pricing is determined by application module subscriptions because with SaaS you're actually accessing an application, right? And it also relies on things like the number of users, the number of consumers, the number of transactions, and things like that, right? So the pricing alignment differs depending on the type of service. These are some ways in which you can measure usage, and then obviously cost based on usage. So if it's a server or a virtual machine, right, you can have a price based on hourly price, right? Or in the cloud now, it's actually per second pricing, right? So you can have a per second pricing, and the pricing could be based on the size of instance or the type of instance, right? So that's one way. You can also have pricing based on the amount of data which is being transferred over the network. So that'll be network usage pricing, or you could have pricing based on how much data has been stored on a storage system, right? That storage device usage-based cost metrics, right? So these are different cost metrics, the way in which you cost or you account for cost, and that's based on how much is being used, right? And the way in which you measure usage depends on the type of service. So with servers, it's usually based on things like how long, right, the type of machine and how long it's been in use for. With network usage, it's usually the data which is being transferred outside, right? Egress traffic, not ingress, not inbound traffic, but outbound traffic. Traffic volume or data transfer volume. And then with storage is how much storage, how much data has been stored, right? How much storage has been consumed. So some additional usage cost metric consideration. So from a network perspective, right? So you typically pay based on traffic, right, across a wide area network. Most cloud providers charge you for traffic, outbound traffic, not inbound traffic, right? So usually inbound network usage is free, right? But outbound network usage, you typically have to pay for that, right? Server usage, so usually you have on-demand or reserved virtual machine allocation, and depending on what you're reserving, there's a certain price for that or cost. And then storage device usage, right? So again, depending on how much data you've actually stored on the disk drive, and also the performance of the disk in terms of IOPS. If you have a solid state drive will cost more than a standard persistent disk, for an example, as an example. Service usage, so this applies mostly to SaaS. So again, based on subscription. So how many users are you paying for? So the more users you have, most likely the cost would be reduced or lower because it's discounted. And then a lot of instances, right, you have a price per user, or you have a price depending on the transactions that each user performs, right? So you would find a combination of these usage cost metrics on the cloud. Some additional discussion or on usage cost metrics. So when talking about network capacity metrics, right? So this is a measurable characteristics of network capacity. For example, 10 megabits per second, right? Or 10 gigabits per second. That's usually for fiber, right? And storage device capacity metrics is a measurable characteristics of storage device capacity. For example, 1 terabyte, 1 petabyte, 2 petabytes, right? Server capacity metrics, measurable characteristics of server capacity, for example, one core, 1.7 gigahertz or 16 gigabytes of RAM, right, 100 gigabytes of storage. And web application capacity metrics is the measurable characteristics of the web application capacity. In other words, the number of requests that can be processed by the application per second or per minute, right? Some additional considerations with respect to usage cost metrics. Also important to think about performance from the point of view of the time it takes for an instance to start, instance starting time metrics, right? So this is the length of time required to initialize an instance. This could be dependent on things like, let's go back here. This could be dependent on things like startup scripts, right? So if you have a startup script that's doing a lot, it may actually take more time for the instance to start. Then you've got here response time metrics, the time required to perform an asynchronous operations. For example, when you make a request, right, how long it takes for a response, right, to be made by the backend system, right, processing the transactions. And then completion time metrics, the time to complete an asynchronous task, right? So those are metrics that could also have an impact on cost as well. Billing considerations. So pricing models are defined using a single or multiple templates that specify unit costs for fine-grained resource usage. I guess that's obvious given what we've just gone through. Fixed rates are based on resource allocation and define the usage quotas included in a fixed pricing. Yeah, that's also, I guess, straightforward. I think we agree with that. Accurate pricing requires the ability to generate accurate IT resource metrics, usage metrics. Absolutely. If you don't have accurate, a way of accurately measuring resource usage, how can you, provide accurate pricing, right? It's impossible. And billing management system is the system that calculates the amount owed, right, over a period of time, like per month or per whatever, right? By tracking historical billing information, we can get insights into insights that help us optimize spend, that helps us understand the usage trends, right? And that information can be quite helpful in saving money, right? So on the cloud platform, customers have the ability to create dashboards and analyze their spend, and a lot of these dashboards are available out of the box. And with prepaid billing, consumers are provided IT resources using credits, right? So with prepaid billing, right, you're more or less, when you provision a resource, the cost of that resource is claimed from the amount you've already paid, right? Okay, so that's prepaid billing. And then with postpaid billing, you basically consume, right, the resources, and then you get billed, right, later, for whatever you've consumed, usually on a monthly basis. Billing usage metrics. So server usage, right, is the on-demand allocation of a virtual machine instance, and the reserved virtual machine allocation metrics, right? So when we're talking about server usage, right, it relates to what virtual machine was allocated on demand or what virtual machine was reserved. Storage device usage refers to on-demand storage allocation metrics, right? So how much was allocated in terms of storage capacity, as well as input-output data transferred metrics as well. Server usage can be based on application subscription duration, the number of users, or the number of transactions users make, right? So those are, I think we've covered those already. Some considerations from a SaaS point of view, from a software as a service perspective. So in a SaaS environment, the consumer is able to manage usage costs, right? Remember, SaaS usually is where you're actually consuming services based on things like the number of users, potentially the number of transactions, etc. Right? So, in a SaaS environment, there are various business models. Sometimes you may have a free tier. Some SaaS services may be offered free of charge, and you only pay when you need to access some more advanced, functions or features. Some are completely free of charge, and the service provider benefits from collecting data and monetizing data. Facebook, LinkedIn being examples of those types of services. And this is the final section. So here we're going to talk about monitoring, service level agreements, and quality of service. Right. So let's start off with another discussion on billing system. Right. So we're going to introduce some new terminology here, but we're also going to cover some of the things we may have covered before. So a monitoring system is a system that records and tracks uptime period, right, and the allocation of IT resources for time-based billing purposes. So on the cloud, you typically have these, and these systems are very accurate because they allow cloud providers to offer per second billing. Now, the pay-per-use monitor typically measures inbound and outbound network usage, right? Remember that most cloud providers don't charge for inbound traffic, right? They usually charge for outbound, right, traffic. The SLA monitor tracks the quality of service metrics such as response times. Very important, because if the SLA doesn't meet what was specified, right, you need to be able to, prove to the cloud provider that you deserve some sort of compensation. Now, pay-per-use monitor can be used. So a pay-per-use monitor can use request response and message quality, transmitted data volume, and bandwidth consumption as metrics, right? So again, it really depends, right, on the type of service, right? So depending on the type of service, any of those could be used or could have an impact on how much you pay. Audit monitors are used to appraise and evaluate regulatory compliance with IT resources. Very, very useful, right? Because you need to make sure, it's very difficult to ensure compliance without automation, right? So if you have a monitor, something that monitors your compliance, right, against regulatory requirements, that's very helpful. Usage monitor. What's a usage monitor? Usage monitor is a lightweight and autonomous software program responsible for collecting and processing IT usage data. And obviously, usage monitor closely aligned with the pay-per-use monitor. The pay-per-use monitor needs usage information to be able to do billing. And usage monitors can be used to track provision IT resources, and they can also be helpful in detecting abnormal usage patterns, right? So that could, result in maybe an IT resource being replaced by another one, right? Maybe health, from a health perspective, health analysis point of view. Data collection by SLA monitors is data collected rather by SLA monitors is processed by an SLA management system, right, in order to allow the aggregation. And usually these management systems have dashboards, right? So SLA metrics or whatever are presented in a form that allows the end user to be able to interpret, right, what the data is actually telling, what the story behind the data is. Some best practices on monitoring, right? So very important to take advantage of monitoring and alerting, right, in order to be proactive instead of being reactive. Now, monitoring is the foundation of a discipline that Google has used successfully to deliver a lot of the billion user services that Google offers. And that practice is called SRE, Site Reliability Engineering. And monitoring and alerting is at the foundation. And it's all because it's designed to enable engineers to be proactive as opposed to reactive. So the idea is to discover problems before the end user actually, before it impacts the end user, right? So one of the benefits of, or one of the recommendations for monitoring is that you should try as much as possible to configure monitoring systems to enable you to get access to the data that you need in order to plan for future resource utilization. We know that the cloud is elastic and you can allocate resources on demand, but it's useful to have a view of just how fast your business is growing and how much resources you're going to need. Also remember that not all types of resources are available in every regions around the world. So when a cloud provider offers a service, they've got data centers around the world, and those data centers are not all the same. Some data centers have more resources than others. So if you have an application or you have a business that's growing really fast and you need resources, and those resources must be deployed within a certain region, you need to have you need to be able to work with your cloud service provider and make sure that you always have sufficient capacity within that region. So you should take preventive action, thereby increasing the availability of servers, services, and application. Absolutely, right? So you should consider the different high availability options that are available. It's usually a trade-off, right, between availability and cost, right? And so you've got to select what actually aligns with your business and the application that you're trying to make available. Also have implement monitoring tools and capability that allows you to very quickly detect network outages quickly. When the Cloud Study Jam website, the application that we deployed, runs on a Kubernetes cluster. It's actually deployed within a single region, right? It's not deployed across multiple regions, but we do have uptime checks. We have uptime checks from the different regions around the world, and we get notified if the service isn't accessible from any one of those regions. Also make sure that you're able to reduce noise, right? So you're not monitoring on things that nobody cares about, right? And whatever is monitored and when an alert is generated, make sure that you can respond quickly, right? And also just generally speaking, that you have the ability to respond quickly to changes in your business needs, right? Changes to your environment, for example, the ability to scale up quickly and obviously scale down as well when you don't need those resources. Um, Monitor without placing a major performance burden on the environment. That's one of the things that I like about the Google Cloud. A lot of the monitoring services and even the debugging tools that you have on the cloud have absolutely no impact on performance. And I think that's remarkable because in the old days, I'm used to having application development platforms that had a significant impact on application performance because just the burden on the addition based on the additional amount of data that was being generated just slowed things down, right, to a halt, right? So currently a lot of these systems, you can perform monitoring and without any performance impact whatsoever. So manage the performance. This is another best practice to manage the performance of the enterprise and provide detailed information on current usage of the environment. That kind of ties into you knowing exactly what you need, right? So try as much as possible to proactively manage, right, the performance of the enterprise and have clarity on resource usage requirements, right, within your environment. Monitor to ensure the overall health of the environment, right? Monitor to show the actual use of compute resources, right? And measure services against their SLAs, right? So these are all, best practices that enable you to transform your operations organization into an SRE, into a site reliability organization, right? So site reliability engineering is all about reliability. It's about not getting into a position where customers have visibility of problems within your infrastructure. Monitoring implementation, right? So let's talk about discuss some, considerations that things you may want to take into account when implementing monitoring, right? So a key component of a successful operating environment is one that so monitoring is basically a key component of a successful operating environment. That's a key point here, right? Something that needs to be available more or less all the time, 24 by 7, right? Monitoring is key, right? Monitor and manage environments efficiently, so you can respond to issues, right? And you can raise alerts or respond to alerts that are raised, right? So monitoring, like I said, is a key foundation of site reliability engineering. Give the administrator, and make sure that monitoring gives the administrator a view of the entire environment through the administration portal or dashboard. In a lot of operation centers, they usually have big monitors on the wall. And so, operators sitting and working on their desktop also can just look up and they can see exactly what the state of their entire environment is. That's always useful, right? Consider web services to aggregate metrics across different environments, right? Whether or not you're using web, in a lot of instances, web services is the way in which you access resources anyway, right? But the key point here is try as much as possible to aggregate all of these metrics into a single dashboard. Do not fragment your monitoring, right? It makes it difficult for you to have that end-to-end view, right? Plan and decide what administrators need to be notified of to avoid issues not getting the attention they deserve. We talk about noise, reduce the level of noise, reduce unnecessary clutter, focus on actionable items or activities. Automate housekeeping activities such as deleting files, using a disk cleanup program. So there are certain things that you don't really have to do manually. So try as much as possible to automate. In fact, site reliability engineering is all about automation. They talk about automate, automate, automate. And that's why site reliability engineers are essentially developers, because they're developing tools and utilities, right, for automation, right? Configure alerts to trigger programs or to trigger a program or a script to automatically start to take corrective action. In other words, implement self-healing capabilities. Automate minor tasks to save the administrator time and enable focus on more pressing issues, right? Again, I did mention automate, automate, automate. That's exactly a key best practice for site reliability engineering. Let's talk about SLAs, right? So what's an SLA? An SLA is a service level agreement, right? So an SLA is a contract between the provider and the consumer, right? So this contract, right, defines, responsibility. It defines the services as well as the responsibilities. SLAs are issued by the provider. These are human readable documents. They are legal documents. It describes quality of service features, guarantees, and limitations. SLAs use quality of service metrics in order to express measurable quality of service characteristics. An SLA management system is a system that uses the metrics and the SLA metrics in order to verify compliance. Compliance with service level agreement guarantees, right? And it also provides various ways, right? Various types of statistical analysis, right? So it gives you a mechanism where you can analyze, just how compliant you've been over maybe a period of time, right? And periods of non-compliance and stuff like that. So service level agreement is a focal point for negotiation, right? It defines the contract terms, right? Legal obligations, runtime metrics. So obviously when someone makes a promise that's captured in the SLA document, that needs to be quantified. There has to be clarity on how that's measured, right, and accounted for. So service level agreements formalizes the guarantees put forward by the cloud provider, and it influences or determines the pricing models and the payment terms. So it's a very, very important document. So some of the considerations, SLA considerations are, so SLAs and the related service quality metrics should be understood, right, and aligned in support of your business, in support of the customer's business requirements, right? So, you can't take SLAs for granted, right? They really need to be understood. It's important to ensure that any guarantees that are made by the cloud provider can in fact be realistically fulfilled consistently, right? And reliably by the provider, right? The service level agreement sets customer expectations and are integral to the design of business automation around the utilization of IT resources. Now, guarantees made by the provider to a consumer are often carried forward to all third parties relying on the services and solutions. And you're going to see that when we get to the cloud. In the cloud, when we start exploring the cloud, we're going to talk about networking between the cloud and an on-premises data center. So there are instances where you need the support of a third party. In other words, if your data center is in a location which cannot connect directly to the cloud, you may have to you may have to take advantage of the service provided by third party. And you see in those instances that the SLAs that are provided by the cloud provider are actually carried forward, right, to the cloud carrier or the partner that you use, right? And the partner hopefully will then also offer similar terms, right, to you as the customer. So some SLA characteristics, these are very important, right? So sometimes you see people use the word smart, right? But this is I actually like this, right? So SLAs must be quantifiable, right? So the unit of measurement must be clearly set. It must be absolute and it must be appropriate so that the metrics can be based on quantitative measurements. Then the second point is that it must be repeatable, right? So the method of measuring the metrics needs to yield identical results when repeated under identical conditions. It must be comparable, right? So the unit of measurement used by a metrics needs to be standardized and comparable. There has to be no ambiguity. It needs to be easily obtainable. There's no point having a service level agreement based on a metrics that the customer doesn't have access to. So the metrics needs to be based on non-proprietary, common forms of measurement that can be easily obtained and understood, right? So again, when you're looking at going through your SLA terms and conditions, always have this in mind, right? Always challenge yourself. Are these the right sort of measurements? Can these terms realistically be met? So some SLA implementation guidelines, right? So identify the necessary quality of service requirements, right? And link to the guarantees expressed in the service level agreement, right? So quality of service guarantees issued by or issued in an SLA in a service level agreement for cloud-based IT resources are generally superior to those provided for on-premises IT resources. That's actually true. A lot of organizations don't actually believe that the cloud gives you more guarantees from a quality of service perspective. And that is credit to the level of engineering in the cloud. It's very difficult to match the level of sophistication and capabilities in the cloud on premises. Right? Understand quality of service when building hybrid cloud-based solutions, especially services that burst across different clouds like cloud bursting architectures. Acknowledge the extent to which a given IT resource guarantee applies. Service level agreements need to specify where monitoring is performed and where measurements are calculated. Right? The SLA templates, service level agreement templates used by the service provider sometimes defines guarantees in broad terms. Right? The level of detail should be appropriate. So again, this is why you need to review these documents carefully, right? Where there's a lack of clarity, you need to make sure that the relevant level of detail is provided. Recourse for failure to deliver quality of service should be formally documented in terms of compensation, penalties, reimbursements, or otherwise. So it should be very clear what the consequences of non-fulfillment of the service of the terms in the service level agreements are. So guarantees which cannot be easily measured using quality of service metrics but are relevant to the quality of service should be documented within the SLA. So don't just leave them out because they cannot be measured. They should be documented as well. The SLA should state the tools and practices used to carry out compliance verification and any legal auditing requirements, right? Or legal related auditing requirements. Metrics being used to measure SLA should be part of the SLA document, including the formulas, not just a description, but including the formulas and the calculations the metrics are based on, right? Use a third-party organization to perform independent monitoring where there are suspicions that the SLA guarantees are not being met or not, usually being met, not being met all the time. For privacy reasons, the provider should disclose if it intends to keep SLA data specific to a customer for an extended period of time, because obviously that's customer related data, right? It's data about the customer's use of resources. Also understand if any leased IT resource or resources has dependencies beyond the environment of the provider organization. Right? So these are some important points regarding quality of service metrics definitions, right? So these are what you are likely going to come across when in the cloud when kind of having discussions on quality of service metrics. In other words, ways in which you can measure the quality of service. So one of the most, in fact, the most common one is availability, right? So availability refers to uptime, right? And that obviously has an impact, or outages have an impact on availability, right? And ultimately service duration, right? How long the service is accessible for. Reliability, typically this relates to the minimum time between failures, or the guarantee, or what's the guarantee that the service will always respond, right? So that's essentially reliability. Performance tend to speaks to the capacity, right? The response time, right? And delivery time guarantees. Scalability, so performance is not just about whether the service is available, and response is also about the time it takes, right? So scalability, tends, refers to the ability for the service or the infrastructure to fluctuate, right, and to adapt or to align with the performance or the resource requirements to deliver a specific level of response guarantees or responsiveness, right? So the whole idea behind scalability is that the amount of resources that are required and allocated in order to meet, right, the expected responsiveness. Resiliency is refers to the mean time to switch over, or the time it takes to recover from a failure incident, right? So that's usually the metrics, right? So when when defining resiliency, the metrics you typically use is the mean time to switch over and recovery, right? So again, what you see here are different metrics that you would probably consider when for each of these quality of service areas. So availability, you may find yourself measuring uptime, measuring outages, service duration. Reliability, you may have to measure the minimum time between failures, right? And then performance, response time, scalability, responsiveness, right? And then resiliency, mean time to switch over and recovery. Some additional points regarding quality of service metrics definitions, right? So these are definitions, right? So we typically talk about service availability metrics. When we talk about service availability metric, that usually includes availability rate metric and outage duration metric. Service reliability metric typically includes the mean time between failures, right, and the reliability rate metric. Service resiliency metric refers to the mean time to switch over, right, and the mean time system recovery metrics. Service performance metrics includes network capacity metrics and storage capacity metrics, and service scalability metrics relates to server capacity, that's horizontal metrics, or vertical. Server scalability, right? So server scalability metrics relates to vertical or horizontal scalability metrics. Okay, so that's that. And then availability rate metric, right, is the overall availability of an IT resource expressed as a percentage of uptime. So for example, minimum of 99.5% uptime. Outage duration metrics defines the maximum, right, an average continuous outage service level target, for example, 15 minutes on average. The mean time between failure metrics is the expected time between consecutive failures, right, for example, 90 days on average, right? And the reliability rate metrics is the percentage of successful service outcomes under predefined conditions, e.g. 99.5%. right? And these are some additional quality of service metrics. Server scalability, horizontal metrics, is the permissible storage device capacity changes, right, in response to increased workloads. For example, 1 terabyte maximum or one virtual server minimum. Server scalability, right, vertical metrics, the permissible server capacity fluctuations in response to workload fluctuations. Mean time to switch over metrics, is the time to complete a switchover from a severe failure to a geographical area. And mean time to recovery metrics is the time for a resilient system to perform a complete recovery from a severe failure, right? And finally, I think this is the last slide, right? So these are some additional quality of service metrics. So you also have network capacity metric, right? Network capacity metric is the measurable characteristics of network capacity. And then we have storage device capacity metrics, which relates to storage device capacity, which is obviously the size, like a 1 terabyte storage. Server capacity metrics is the measurable characteristics of server capacity, right? This is usually the machine type. And web application capacity metric, measurable characteristics of web application capacity, for example, the number of requests that the application can handle per minute or per second. Instance starting time metrics, the length of time it takes to initialize the instance. Response time metrics, the time it takes to perform a synchronous operation. And then completion time metrics, the time required to complete an asynchronous task. Right, so this is just a consolidation of all the different quality of service metrics, and we've probably seen some earlier in the presentation. Right, so this was a long one, a lot to digest. I hope you found it useful. I personally see a lot of this as a reference. So as you're working on the cloud from time to time, it may be worth coming back to some of these best practices and recommendations and translating this right into what's available on the cloud. Okay, thanks for watching and see you in the next session. Take care.